Hello everyone and welcome to Know Where You There Is. This is your host Mahmoud Nower. Today we'll be going through organic chemistry's own nomenclature. We'll be discussing the common nomenclatures and what are they and naming rules as well. So let's dive deep into it. It's going to be a short video but informative. So you need to know the functional groups, right? So the way we know the functional groups is alkane, single bond, alkene, double bond, alkyne, triple bond. So remember, ane, single, ene, double, yne, triple bond. Then you got the alcohol. Alcohol is just bonded to an OH. So whenever you see a, a simple, like, I don't know, compound with just OH, so let's say CH3OH, that's an alcohol, right? Then you have alkyl halide, the alkyl halide. So that's where compounds are bonded to halogens such as fluorine, Cl2, and Br. Halogens are found just before the noble gases, so they're found in the seventh column. Amine is bonded to a nitrogen. So, uh, but it's different than an amide. We're going to be discussing that later. So an amine is just bonded to a nitrogen, as you can see here. Then you got an aldehyde and a ketone. So we're going to speak about both of them. So an aldehyde is a carbon double bonded to an oxygen, as you can see here, and it's bonded to an H and an R group. So the carbon double bonded to oxygen, that's a must, and has to be bonded to an H as well. And then the C must have an R group. So what do I mean by an R group? An R group is basically anything, but common R groups include like hydrocarbons, methyl, ethyl, etc., etc. Next, we have the ketone. Ketone is double bonded, a carbon double bonded to oxygen with two R groups. So usually a ketone is found in the middle, okay, because it's like surrounded by two hydrocarbon R groups. Okay, next we have amide, the one I mentioned before. So an amide is similar to an amine in which it's bonded to a nitrogen. So an amide is bonded to a nitrogen. So what makes an amide special is double bonded to an oxygen, just like ketone and aldehyde, but it's also bonded to a nitrogen. Alright? So double bonded to an oxygen, and the nitrogen is a single bond. Okay, and the amide is bonded to an R group. So here, look at this side. All right, just don't look at the H and the CH3 for now. So an amide double bonded to oxygen, single bonded to a nitrogen, and then there's the R group. Next, sorry, I skipped over carboxylic acid. So going back to carboxylic acid is double bonded to an oxygen and OH. So we thought we saw the OH only in alcohol. No, carboxylic acid also has an OH group, so and has an R group. Alright, so double bonded oxygen, OH group, R group. Next we have an ester and an ether. So an ester is basically a carbon double bonded to oxygen, and then it's bonded to an oxygen that is bonded to an R group. So what makes an ester special is that it has two oxygens. So this single carbon is double bonded to an oxygen and single bonded to an oxygen, and the same carbon is bonded to an R group. So what makes this ester special is that the oxygen is bonded to an R group as well. So it's a whole unit here. So R group, and then oxygen and double bonded oxygen. With an ether though, it's just an oxygen bonded to two R groups. No double bonds, no nothing. So what's the difference between an ether and a ketone? A carbon is double bonded to an oxygen. Here the oxygen is it's single bonded to the R groups. So when naming nomenclature, so you're gonna have, for instance, like a structure like this. You're gonna have some like this. You know, you're gonna face some like chains and groups and stuff like that that could seem a little bit um, challenging, but really it's not. So the first rule is identify the parent longest chain and the substituents in the lowest groups. So you identify how many carbons is in the group. So you got like here, carbon here, one, two. So that's a pentane. Okay, so that's how many carbon in the group, for instance. And then let's say you have, I don't know, a methyl group here, position 1, position 2, all right? And then you're like, oh, so you say 2,3-dimethyl, for instance. So you don't say methyl methyl, but because they're like the same kind of like substituents together, they're grouped. Then you alphabetize the substituents and not by number, because we mentioned then there is numbering as well. All right, so it's by priority is by alphabetizing, so by alphabets. All right, so you have here, I don't know, methyl, and then here you have an ethyl group. So which one goes first in the alphabets? It's the ethyl. So which one is closer? It's 1, 2, 3, 1, 2, 3. It's about the same. So 3 ethyl and 4 methyl, for instance. You know, and that's how. And then you say the structure is like 3 ethyl, 4 methyl pentane. Then so remember how I was speaking about the structural formula and like the hydrocarbons and stuff like that. So you got here, methane means 1 carbon, 4 hydrogens. Ethane is 2 carbons. Propane 3 carbons. Butane 4 carbons. Pentane is 5 carbons. Hexane is 6. 7 heptane. Octane is 8. 9 is nonane, and 10 is the decane. Alcohols with 2 groups are diols or gysols. Alright, so you could face, you know, something like that has 2 OH groups. Okay, you have just 2 OH. So this is a diol. Alright, and then you have an aldehyde that has a carbonyl group usually attached to a carbon, and you change the ending to an Al. So let's say you're naming something. If, let's say this was, what did we say the aldehyde is? So the aldehyde is basically double bonded, and then there needs to be an H, and there needs to be a R group. So we're gonna just choose methyl. Okay, for our group, so let's say we have this, it needs to end with an Al. Alright, that's the rule. It needs to end with an Al if it's an aldehyde. So sugars are either aldehyde sugars or ketone sugars. So you can have like glucose, fructose, stuff like that. They're aldehyde or ketone. Carboxylic acid contains the carbonyl and hydroxyl group, and it ends in oic acid. So benzoic acid, you know, there's a lot of I can't name one on top of my head right now, but it has to end with a oic if you find a carboxylic. So carboxylic is double bonded oxygen and a OH. So esters, common derivatives. So OR group, carbonyl group, you replace it with oic or with IOH. So ethyl propanate. Okay, that's an ester. So we said the ester is what makes the ester special, double bonded, and then N, and then you got the R group, and then you end it with OH. Anhydrides can be cyclic, derived from acid bonded to oxygen, for instance, ethanoic anhydride. So you end it with the anhydride if it's like cyclic and it's bonded to an oxygen. So you can have it like that, something like that. and then you call this an anhydride. All right, thank you so much, everyone.